Hi, you did it. You made it to the end of our fractions chapter in math. We're going to do a little review, and I'm going to show you the test you're going to take today. So just so you know, we had four outcomes or four objectives that I was teaching toward this chapter. The first one was simply just naming these fractions. It can be really tricky sometimes to think about what they're called. So let's see here. This has kind of a funny name. This is called 1/2, right? Or 1 out of 2, and it means that you cut something in half. This one is called 1/3, and it means you're cutting something into 3 parts, right? 1/3 or 1 out of 3. And here we are cutting something into 4 parts, and you could say 1/4 or even 1/4 or 1 out of 4. It keeps going from there, like 1/5, 1/6, 1/7. So if you're ever mixed up by those ordinal numbers with the th at the end, you could always just say 1 out of 4. It's perfectly fine. 1 out of 3. I don't think we would ever say 1/2. We would say 1 out of 2. Okay? So that was one of our lessons, just learning how to name these new numbers we're dealing with. All right. I think, honestly, the first thing we did, even before we started talking about naming those numbers, is we looked at what is and is not a fraction. A fraction has to be equal, right? So when you take a whole pentagon or a whole arrow or a whole house and you cut it into parts, those parts all have to be the same size. That's what equal means. These two don't seem to be the same size. They are unequal. So this is not a fraction. But this one is. This is 1/2 of the arrow. It's the same size as the other half. This is not a fraction because they're not the same. One is a rectangle, one is a triangle. They are not equal. This is not a fraction. This is like a quarter of a pie and then half a pie. It's a little bit mixed up. I'm not sure what they're doing. But here we have a fraction again because it's cut nicely into equal parts. So on our test today, you're going to identify things as equal or not equal. Excellent. That should be a little bit of review for you. So the idea here is that if you cut something apart, you could put it back together, couldn't you? Right? It would take 2 halves to go together to make one whole again. So you can put fractions together to make a whole. It would take 3/3 to go together to be a whole. Let me show you what that would look like. So if I put 3/3 together, this whole thing, 1/3, 2/3, 3/3, it would look like this. 3 out of 3. I have the whole thing. And then you could, if you wanted, just call it one whole, right? Same thing here. It would take 4 parts. I'm going to change color to do this one. 1, 2, 3, 4. So I would have 4 out of 4 equaling one whole. So if the number on the top, the numerator, and the number on the bottom, the denominator, are the same, you get one whole because you have every piece possible. Here, I would need 6 out of 6 to be a whole. Here, I would need 2 out of 2 to be one whole candy bar. 1. 2 pieces would give me a whole thing. It just depends how many pieces you have when you cut it up. However many you have to have them all. Otherwise, you don't have a whole. So you have to have all the pieces possible. All right. The last part can be simple or it can be tricky, depending how you think about it. So the first thing I'm going to tell you is that numbers like 17 are tricky. So let's work around 17 first. We're going to save that one for last. So there are really 2 parts of this problem. There's the numerator on the top, And then there's the denominator on the bottom. The numerator tells you how many parts you have, how many parts you're getting, how many parts are moving, how many parts are changing. That number is going to move around. The denominator's not. If you start with monkeys, you're going to end up with monkeys in the problem. If you start with bananas, you're going to end up with bananas. If you start with bicycles, you're going to end up with bicycles. So what I mean by that is if you start with fourths, the fourth stays the same all the way through the problem, even into the answer. Same with the thirds. If you start with thirds, it's going to stay the same. Same with the fourths, it's going to stay the same. The only part you have to change is the top part, and it just depends what they're asking you to do. Here, I'm asked to add. I have one part, and I get 3 more parts. 1 plus 3 is going to give me 4 out of 4, which actually is the whole thing. Interesting. This is a fine answer, and if you want to show it like this, this is a fine answer too. If I have 2 parts and someone gives me another part, I'll end up with 3 out of 3. Hold the phone. That's the whole thing again. Both of these would be acceptable answers. This one I'm asked to subtract. So this would be me having 3 parts and someone takes 2 of those parts away. I'm left with only 1 part. 1 out of 4. 1/4 would be the answer here. Now, the reason 17 is tricky is because I'm starting off with 1 whole. I don't really want 1 whole. I want fourths. See how I'm subtracting fourths? I need to make that fourths. So the way you do that is you just take whatever it is, 1 whole candy bar, and you cut it up into 4 equal pieces. And you say, no, I don't actually have 1 whole. I have 4 fourths. See, I have 1, 2, 3, 4 fourths. Oh, it means the same thing as 1 whole, but now I'm able to subtract it. Before it just kind of was confusing, but now I can see I have 4 fourths and someone takes 1 of my fourths away. So I'm left 4 take away 1 with 3 fourths. The fourth still doesn't change at the bottom. The denominator stays the same. That's part of being a like fraction. When you're adding and subtracting fractions, they always have to be alike. All right, this is the test you're going to take. Put an X, right, if it's equal. So I want you to put an X by the ones that you like, that are fair, Don't do anything to the ones that are not equal. This is interesting. You have to make these equal, right? So here you have to divide this into 4 equal parts. So you might say, well, there are 2 equal parts. And now I have 1, 2, 3, 4 equal parts. Down here, you have to put an X on the weirdo. So this says 1/4. This says 1/4. This says 1/4. This one, though, doesn't. This says 1/3. That's the weirdo. Cross it out. On the back, you have to count all the parts and write the denominator. Then look at how many are shaded. Write the fraction. Here, you're asked to take 2 fractions, like fractions, they're both fourths, and put them together by adding to get the answer. So add 2 fourths and 1/4 to get the answer. Same thing here, except you're subtracting now. You have like fractions. You're going to subtract to get the answer. More adding and subtracting of fractions down at the bottom. I have given you a model to help. If it was me, I would color in the model. 1/4, let me just color that in, plus 2 fourths. How much is it all together? Goes on the line. Use the model if I give you one. After this, there's a great math game for you on the next slide. Thanks now. Bye.